Welcome back to VLAB Solutions, your ultimate resource for mastering machine learning and MLOps. Today we're going to explore how to design, develop, and manage production-level machine learning pipelines that stand up to real-world challenges. In this video, we'll break down every step, from setting up data pipelines to monitoring models for performance, and discuss the best tools to use. So, if you're serious about scaling ML systems and getting your models into production, you've come to the right place. Let's jump right in. Let's start with the basics. What is an ML pipeline and why is it critical for production-level machine learning? You see, building a machine learning model is just one piece of the puzzle. To truly leverage the power of ML, you need to deploy it, and that's where pipelines come in. Think of an ML pipeline as an automated sequence of steps that takes your raw data, pre-processes it, trains your model, and then deploys it for real-world use. It's like the assembly line of the ML world, ensuring a smooth and efficient transition from raw data to a functioning model. Without a pipeline, you're stuck manually managing each step, which is time-consuming, error-prone, and difficult to scale. And we all know how much we hate things that are difficult to scale. For example, imagine you're building a recommendation system for an e-commerce platform. Your ML pipeline would handle everything from collecting user data to deploying the model that suggests products. This streamlined process ensures that your model is always up to date and delivering accurate recommendations. So, whether you're a seasoned ML engineer or just starting, understanding ML pipelines is essential for building and deploying robust, scalable, and efficient machine learning systems. Creating a robust ML pipeline starts with solid data pre-processing and feature engineering. Let's dive deeper into these components. Now let's talk about building the foundation of any successful ML pipeline: data pre-processing and feature engineering. This stage is all about transforming raw data into a format that our machine learning models can understand and learn from. It's like prepping ingredients before you start cooking. The quality of your ingredients directly impacts the final dish. Data pre-processing involves cleaning, transforming, and preparing raw data. We're talking about handling missing values, dealing with outliers, and converting categorical variables into a numerical format. Feature engineering, on the other hand, is about selecting, transforming, and creating relevant features from the existing data. This step requires a deep understanding of the data and the problem you're trying to solve. It's about finding those hidden gems within the data that can significantly improve your model's performance. For instance, you're building a model to predict housing prices. You might combine features like the number of bedrooms and bathrooms to create a new feature called total rooms, which could be a more powerful predictor. By mastering data pre-processing and feature engineering, you're setting the stage for a well-trained, accurate, and efficient machine learning model. Remember, garbage in, garbage out. So a strong foundation is key. Automating model training is crucial. You don't want to retrain models manually every time you get new data. This is where frameworks like MLflow and TFX, TensorFlow Extended, shine. Alright, let's talk about automating model training, a critical aspect of any production-level ML pipeline. We don't want to be stuck manually retraining our models every time new data rolls in, right? That's where tools like MLflow and TensorFlow Extended, TFX, come into play. These frameworks provide the infrastructure and tools to automate the entire training process, saving us time and reducing errors. MLflow, for instance, helps manage the entire machine learning lifecycle, including experimentation, reproducibility, deployment, and a central model registry. It allows you to track experiments, package code into reproducible runs, and share and deploy models. On the other hand, TFX is a powerful platform specifically designed for TensorFlow users. It provides a set of components for building scalable, high-performing machine learning pipelines. Think of it as a one-stop shop for deploying production-ready TensorFlow models. By automating the training process, you free up time for other essential tasks like model optimization and deployment. Plus, it ensures that your models are consistently trained on the latest data, keeping them relevant and accurate over time. Whether you choose MLflow, TFX, or another framework, automating your training process is a game changer for any serious ML practitioner. Deploying models efficiently. Now let's talk about deployment. Deploying models at scale can be a nightmare if not done correctly. Tools like Kubeflow help orchestrate machine learning workflows on Kubernetes. We've built our models, trained them, and now it's time to unleash them into the real world. But deploying machine learning models, especially at scale, can be a real headache. This is where tools like Kubeflow come into play. Kubeflow is an open-source platform built for deploying and managing machine learning workflows on Kubernetes. By adopting tools like Kubeflow, you can streamline the deployment process. Monitoring models in production. Monitoring models in production is a continuous process. You need to keep an eye on metrics like accuracy, latency, and throughput. But one of the biggest challenges is model drift. Alright, our models are live and making predictions, but the work doesn't stop there. Monitoring models in production is an ongoing process, like tending to a garden. We need to ensure our models are performing as expected, identifying and addressing any issues that might pop up. This means keeping a close eye on critical metrics like accuracy, latency, and throughput. Accuracy tells us how well our model is making predictions, latency measures how quickly it responds to requests, and throughput indicates how much data it can handle. But one of the biggest challenges we face in production is model drift. This happens when the performance of our model gradually deteriorates over time due to changes in the data or the relationship between input and output variables. Imagine training a spam detection model on emails from a few years ago. The nature of spam emails has likely evolved, meaning our model might not be as effective. That's why continuous monitoring and retraining are crucial for maintaining the accuracy and reliability of our models in a dynamic environment. Continuous optimization. Optimization doesn't end after deployment. Your model needs continuous fine-tuning, especially in dynamic environments where data evolves constantly. Deploying a machine learning model isn't a set-it-and-forget-it situation. The world is constantly changing, and our models need to keep up. That's why continuous optimization is essential for maintaining a model's performance over time. Think of it like tuning a musical instrument. It needs regular adjustments to stay in harmony. Continuous optimization involves regularly evaluating the model's performance, identifying areas for improvement, and making necessary adjustments. This could involve retraining the model on new data, tweaking hyperparameters, or even exploring new algorithms. The goal is to ensure the model remains relevant and accurate, even as the data it's processing evolves. This is especially crucial in dynamic environments where data is constantly changing, like financial markets or social media trends. A model trained on yesterday's data might not be equipped to handle tomorrow's challenges. By embracing continuous optimization, we ensure our models remain adaptable, effective, and deliver accurate results over the long haul. Collaborate and communicate. One of the most overlooked aspects of MLOps is collaboration. Data scientists, ML engineers, and software developers need to be on the same page. Now let's talk about a critical aspect of MLOps that often gets overlooked: collaboration. Building and deploying machine learning models isn't a solo mission. It's a team effort. Data scientists, ML engineers, software developers, and even business stakeholders need to be on the same page to ensure success. Think of it like a basketball team. Everyone has their own role to play, but communication and teamwork are essential for winning the game. Data scientists might develop the models, but ML engineers focus on deployment and scaling, while software developers integrate the models into existing systems. Effective communication ensures that everyone understands the project goals, the model's capabilities and limitations, and any potential challenges. This shared understanding streamlines the entire workflow, reduces errors, and fosters a more cohesive and productive environment. Tools like version control systems, shared code repositories, and communication platforms can facilitate collaboration and ensure everyone is on the same page. Staying ahead. Lastly, MLOps is a rapidly evolving field. New tools and techniques are emerging all the time. To stay competitive, keep an eye on developments in the community. As we've seen, MLOps is a dynamic and ever-evolving field. New tools, techniques, and best practices are constantly emerging, and staying ahead of the curve is crucial for any ML practitioner who wants to remain competitive. The world of technology never sleeps, and neither should our thirst for knowledge. It's like navigating a constantly changing landscape. We need to be aware of the latest developments to choose the right path. So, how do we stay ahead? Engage with the MLOps community, attend conferences and webinars, read blogs and research papers, and experiment with new tools and frameworks. The more we expose ourselves to new ideas and approaches, the better equipped we'll be to tackle challenges, innovate, and build even more robust and efficient ML pipelines. Remember, the learning never stops in the world of MLOps. By embracing a mindset of continuous learning and exploration, we can ensure our skills remain relevant, our models remain cutting edge, and we stay ahead of the game. Conclusion. And there you have it. From designing data pipelines to monitoring and optimizing models, MLOps covers a vast array of skills and tools. If you found this video helpful, make sure to give it a thumbs up, subscribe, and hit the bell icon for more deep dives into machine learning. Have questions or want us to cover a specific MLOps topic? Drop a comment below. Thanks for watching and subscribe to VLAB Solutions.